Hello, everyone. So the last few days we really looked at solving logarithmic equations. And remember, a logarithmic equation is when we look at the problem and there's a log in it. Today we're going to kind of shift gears and we're going to look at exponential equations.
Mom, exponential.
Nice. All right. So far we have learned how to. I see that, buddy. So far we have looked at one way to solve exponential equations, and that is by getting the same base. And then once we have that same base, we can set the exponents equal to each other. So let's go ahead and do a warm-up problem like that. So I want to solve 2 to the x plus 3 power equals 64. So again, first thing we want to do is get the same base. So I believe I can get 64 to have a base of 2. Let's see. Looks like 2 to the power, does that help? 2 to the power of 6 equals 64. And again, one thing I want to point out is that this still has the same value. This still equals 64. We just manipulated the way it looks. All right. And now that our bases are the same, we can set our exponents equal to each other and solve. So I'm going to subtract 3 from both sides, and it looks like we're going to get x equals 3 for solution. And then we have no log in the problem, so we don't need to check to make sure that our arguments remain positive when we plug those things in. All right. Today, then, we're going to look at problems where we can't get the same base. So problems like this. So we have 7.6 and 24. And again, there's no way we can get the same basis for these. It's not possible, okay? So what we're going to do in order to solve these is we are going to take the common log of both sides. So I'm going to log both sides. So I'm going to rewrite this quick. And remember I said the common log. And notice there's no base written here. But remember the common log, when there's no base written, that's really at 10. All right. So I went ahead and took the log of both sides. And notice I have an exponent up here. And remember, another thing you can do with exponents is you can move it to the front as sort of a multiplier. So that's actually what I'm going to do right now. I'm going to move my exponent to the front. And notice I put parentheses around it. That is important. All right. Next thing I'm going to do, log of 24 and log of 7.6, they look really, really scary, but it's just a number. So what we're going to do is we're going to go ahead and plug those into our calculators. Your calculator can do a common log, and I'm going to get the decimal approximation for that. So log, this is what my log button looks like. So I'm going to hit log of 24, and I'm going to do 3 decimal places. So that would be 1.380. And I'm going to do that same thing with log of 7.6. So that'll round up to 0.881. Again, I want to do 3 decimal places. And now we don't have the nicest of numbers to work with, but I know now you guys can all solve this equation. So next thing we would do is we would go ahead and distribute that into those parentheses. So let's see, 0.88 times 2 is going to give us 1.762x when we distribute that in. Then I'm going to have a plus 0.881.
Mom, it's here.
Okay, you're going to have to press the button.
The button will be black.
And now to solve this, I'm going to go ahead and subtract that 0.881 from both sides. And then I'm going to go ahead and divide both sides by 1.762. And my approximate answer is going to be 0.283. Now, again, you don't need to plug this in because there's no logs in there, but I want to just to show you guys, just to show how to check your answer. So I'm going to have 7.6 to the power of 2 times our answer plus 1. And if I hit enter, notice we said it was going to equal 24 up here. If I hit enter, I get 23.95. So notice we're a little off. And the reason we're a little off is because we had some rounding things going on. If we would have wrote this full decimal out, then it would have been probably spot on. But because we rounded 3 times in our problem, that is why it is a little off when you plug it in. Okay, so know that. All right, let's do a couple more. Let's see. Ooh, so notice we have exponents on both sides this time, but our directions are still the same, still the solve. So again, there's no way I can get 3 and 5 to have the same base. So what we're going to do is we're going to take the log again of both sides. And then again, same thing, we can move our exponents out in front, making sure we keep parentheses around them. Next step, again, I know the logs is just a decimal approximation, so let's go ahead and figure that out. So log of 3 is 0.477. And let's see, log of 5 is 0.699. That would round up. And again, it's not the prettiest, but you guys can all solve it. Let's go ahead and multiply this out. So I would get 0.477x plus 0.477. And then over here, 0.699 times 2 will give us 1.398 times x. And now a simple equation to solve, I need to go ahead and subtract 477x from both sides. And on my last step, I need to divide both sides by 0.921. And let's see, I want to round to 3 decimals, so this will be 0.518. And again, I could go ahead and plug those in, and it would give me 2 very, very similar expressions. All right, let's do one more. So this time we have 2 to the negative x minus 3 equals 3 to the x plus 1. Again, there's no way I can get 2 and 3 to have the same base. So we are going to take the log of both sides. And again, one of our properties of exponents is we can move, or the properties of logs says we can move the exponents out front. So that's what I'm going to do. Next, I'm going to go ahead and get these decimal approximations for our logs. So log 2 is about 3, or 0.301. And log 3 is 0.477. And then it's messy, but it's a pretty simple equation to solve. So I'm going to go ahead and distribute that in. Let's see, I'm going to add 0.301x to both sides. And I'm going to subtract the 0.477.
Mom, too fast.
Nice. And then my last step, I need to divide both sides by 0.778 to get my answer of negative 1.774 if I round to 3 decimals. All right. And again, you don't need to check this, but let's go ahead and do that. So I'm going to plug it into this side first. Not like this. That's hard to see. Okay. So we have 2 to the power of negative 1.77. So that's going to become a positive, actually, minus 3. So notice that's what this side over here equaled when we plug it in. And now let's go ahead and plug it in on this side as well. And notice those two are very, very close. If you can see that there, that's better. And again, the reason it's not spot on is because we had some rounding things going on. All right, there's today's. Have a great weekend, you guys.